Bastian, yeah. Thank you very much. We will now start with the last talk of the day by Bastian Braun. A Doorman for your home. It looks like we changed from web application security to physical security.
Not really, but sometimes pictures help.
Okay, please tell us, Bastian.
Thank you. And sorry for the inconvenience, but I hope you can see all the slides here now. Okay, so what is this about? It is about control flow integrity in web applications. Therefore, we need to first explain how we see web applications in general. So for this topic, it's the easiest way to consider web application as a reactive system. So it is running, which means actually waiting for input, for user requests. When they arrive, they are processed, maybe the local state, databases, whatever, is changed. A response is computed, finally sent back to the user. These pairs of user actions and web application reactions together build a flow, and modern web applications that implement more or less complex business logic, they rely on those flows. And we will identify problems in this context. So popular examples, probably every one of you used one of these to book flight, train tickets, hotel here, whatever, consist of several of these steps where you provide your personal data, payment data, and the like. So, just to give you a really trivial example to make things obvious is when you surf in your web browser, for example, you do some shopping, you fill your shopping cart. In the next step, for checkout, you need to provide username and password. So far, so good. Me as an attacker, I don't care about this, so this is perfectly okay for me. What I don't want is I don't want to spend money for this. But shipping is perfect, of course I want to receive this. Well, here I'm caught more or less, so I need to provide payment details. And Amazon wants me to click on this link here. I must admit that I needed some Photoshop to do this, so this is not real, Amazon is not vulnerable, but it is known to everyone, so this is why pictures help. So what Amazon wants me to do here is to click on those links. What then happens is that they check the validity of the credit card, and they charge me the money. However, what they cannot prevent is that finally I change the address line of my browser. And if I know the final landing and confirmation page, and I enter this URL, I might be able to end up here with this information being empty because it's never been sent to the web application, while the rest of the information was given in former steps. And this is complete. So this is something that Amazon by default cannot protect on my client side. So they need to protect on server side. And this is true for all web applications implementing such multi-step business flows. Real-world examples, so not these dummy examples that I gave, is first a thing that is called race conditions. So we know race conditions from local platforms, from programs. But in distributed applications, like in the web, they are maybe even more dangerous because it's more easy for an attacker to run such attacks. The popular example here allowed the attackers to use a web application that offered to send a free amount of SMS text messages per day, per user account. So I think these were like 5 or 10. What these people did were they crafted requests, HTTP post requests, including the recipient's phone number, the text that was supposed to be sent, and sent them from the command line in parallel. And finally, they found that they were able to send like 15 or 16 messages in parallel, and all of these arrived. Because the update in the database in the background took more time than the first process of the processing of the requests. And this finally allowed them to send more messages before the threshold was reached. Another example was plain old HTTP parameter manipulation. In these two examples, it was actually a data leak. The first one at Citigroup allowed a logged-in user to just count up an integer value as a HTTP parameter, and this way access the accounts of other customers. And these guys were able to obtain data records from other people, like I think 200,000 data records, and publish them in the internet. These were including names, credit card numbers, social security numbers. The other example from UNESCO was actually the same. When applying for a job at UNESCO, you obtained an ID, and this ID was carried in a HTTP request. But of course, it is technically not possible to prevent that people try out different IDs. They did, and they had access to the accounts of other applicants, including their name, their home address, and their current income, their yearly salary. The third example was more or less similar to what I gave you as a dummy example. This allowed the attackers to run such a shopping flow, including the payment. But after the payment, they were able to add more items to their shopping cart, which were also shipped but not invoiced. So just buying one cheap item allowed them to be finally served any arbitrary item in the shop. There are even more such examples that all are in this field of falsely handled HTTP requests on web application side. So what they all have in common is there was no explicit control flow definition that would be reviewable, that would be checkable for assessments, for example. Nor was an central enforcement point. So the enforcement happened in distributed modules of the web applications. Finally, as usual, assumptions are the root cause for any vulnerability. So the assumptions were that users access the entry page of the web application, they click on links and buttons, enter information, maybe they even sanitize the input to prevent injection attacks, but there was no injection at all. So the user behavior was different from their assumptions. And finally, the access control in place was either relying on HTTP parameters, like in the case of Citigroup and UNESCO, which modifying them immediately circumvented all access control, or it was not helpful at all, like in the case with the shopping, because what the users did was all within their rights. Of course, they are allowed to add items to their shopping cart. So this is an example where access control cannot help at all. So what would help against all these kinds of attacks would be a central point that receives a definition, how developers assume that this web application is used, and that also enforces this policy. And as this is a really common problem among many applications and currently needs to be implemented in every web application, it seems natural to provide a generic module that is configurable within web application frameworks. So what are web application frameworks? They allow developers to implement the application on a higher level because they abstract from the actual technical details. And this is exactly what we want here, because the developer would only have to define in a policy how he assumes the web application is used. So conceptually, one would integrate a control flow monitor on a lower level than the web application itself. And what we wanted to find out is how far is there any kind of support in existing web application frameworks. And the more common framework is, the higher is the impact, if it has it or it doesn't. This is why we took the top 10 web application frameworks according to a website called BuildWith, which sell or provide statistics on the distribution of any kind of web technologies. And after we performed this, we found that Django as an 11th also has a considerable distribution. This is why we included this as an 11th as well. So what we then did is we wanted to check 3 security features with respect to the attacks that I described earlier. The one is, how far do these frameworks offer support to control the message sequence flow? So that, for example, no item may be added to the shopping cart after checkout. The race condition protection, which makes sure that sensitive requests are processed in parallel, not in parallel, but sequentially. And finally, means to control the request integrity, because changing these parameters might also lead to different data types, which then cause different problems or maybe the root causes for vulnerabilities in web applications. So what we did was, we were first checking all the manuals of these frameworks. We were inspecting the configuration options there because, well, the point of view was like a web developer saying, okay, I will use this framework, and if I don't find any hint on such functionality, I cannot use it. So this was why we were looking for any hints on such functionality. Finally, we were having a deeper look on the flow of requests through this framework. So these frameworks consist of several modules, and we were inspecting these modules whether they are able to intercept requests if they don't fit the intended usage. Is anyone not familiar with the model view controller architecture? Everyone is. Perfect. So, first, the outcome concerning message sequence enforcement is that only one out of these 11 actually provides some kind of support. And this is the Spring framework. Spring is actually only a Java framework. It becomes a web application framework by using a particular web module. And by using this, we can even use more extensions. And one of these extensions is, for example, the Webflow extension. What this does is insert an additional controller, which then checks every incoming request for a policy. The policy describes actually a graph consisting of states and transitions. And if the request describes a transition that is not given in the policy in this graph, then it's not handled by the model and the view. So there's no processing on this request. It does this, or it achieves this protection by adding even more HTTP parameters. And we will see what this finally means. On the one hand, it allows to have several of these workflows within the same browser by having several tabs, for example. Because the web application, so Webflow, is able to tell apart one workflow from the other because the flow execution key differs. So this is still a feature that I, as a user, can still use the web application, the same application with the same account in the same browser. So this allows multi-tabbing. And it also has back button protection, which means that faulty users of the back button are prohibited. But there is still a problem, which is not solved by this framework. It is debatable whether a framework should even protect against this kind of attacks. Nevertheless, having several workflows in parallel also means that users might be able to exchange parameters between two workflows. And this was also described in a popular paper at Security and Privacy in Oakland, where attackers were able to buy items in a shop in one of these tabs, cheap items again, and then they obtained an HTTP parameter stating that the payment was successful. And this token was attached to the other tab and finally directly calling the final confirmation page. This is similar to what I showed in the beginning. And this shopping website accepted this request, saying, okay, this is a valid token, payment was successful, and then they shipped the even more expensive items. So this is a cross-workflow attack, which cannot be prevented by Spring, even using this Webflow extension. The next topic are these race conditions. So there are actually several kinds of race condition exploits and attacks in web applications. So we just consider a really simple workflow. This is what I mentioned in the beginning, like the people sending the SMS text messages. So first, the message text and recipient's number is entered, a post request to the next module is sent, and finally confirmation is displayed. An attack might use several vectors. First, there's an in-tab or in-workflow attack, where after the first step, as an attacker, I just need to take a look on the page's source in my browser in order to see how the next request, when clicking on the send button, would look like. And I can craft any kind of request, appending any parameters necessary, CSRF tokens, whatever is necessary. So I can just multiply the one request to several. This is the kind of, oh, no, come later to this. The next one is a multi-tab attack, which means I start the same sending flow, the same workflow in 2 tabs in my browser, which means I'm still in the same user account, even in the same session, because I have only 1 session cookie in this case. But I have several of these flow IDs. And I can do it with 2 tabs, 3, 4, 5, whatever, and this way replicate the whole flow, not only 1 request. And this, on server side, means that if a protection takes care that 1 request is not processed more than once, it does not help here, because these requests differ in some of the parameters. And finally, this can also happen cross-session, which means if I'm able to log into my user account with 2 browsers in parallel, I finally have 2 sessions with 2 session IDs. But I'm still working on the same user context. And if the web application only grants me 5 messages per day, this must still be enforced, though, of course, I may use an arbitrary amount of browsers at the same time and have the same number of sessions. Having this in mind, the only kind of protection that we found was again by Spring against the in-top or in-workflow attack, the first kind, this one here. And this is probably more a side effect of the message sequence protection, because we needed to append the same flow execution key and the same event ID. And this enabled the workflow, the framework, to identify that 1 request was not only sent once and the tokens were invalidated, but then the same request came again, but then with invalid tokens. None of the tested frameworks protects against any of the other more sophisticated kinds of attacks. Finally, the parameter data type enforcement. This goes a little in the direction of injection attacks. So, of course, if a web application expects an integer, but I finally send them injection code, for example, SQL injection or cross-site scripting code, and it processes in the wrong way, we all know the consequences. So what we found is that the out-of-the-box support for the integrity of data types mainly depends on the underlying programming language of these frameworks. So we had Java-based languages, PHP-based languages, .NET-based languages, Python and Ruby. The Java-based frameworks, they raised exceptions for typecast they were not able to do, which means when they expected integers and we sent them strings, there was an exception. Vice versa, there was none. However, the good news is that all of these frameworks offer the opportunity, the possibility to define regular expressions that are also properly enforced. However, this means that developers need to think of enforcing the data type and defining such regular expressions. So, another good news, more or less, is that most of the frameworks actually provide single points of enforcement. They don't implement these modules that we wanted to see or that we were looking after, but the basis is there already. So what they have is they have dispatchers, and most of them even have so-called filters, which filter incoming requests and outgoing responses. Today they are mostly used for CSRF tokens, for example. To append them to outgoing responses and to read and check them for incoming requests. This is a good basis because this provides almost all necessary input to implement also a control flow integrity module. However, there is currently none. So it is more or less easy to implement one, not easy is too much, but it is possible without major rework, but it is still to do. So, the final outcome of all our frameworks means that there is a lot to do. we are on a good way, I think. But there's still some work left. So none of these frameworks finally has security against all of these attacks by design. However, most of them offer a skilled developer to implement necessary security features. Spring Webflow is the brightest star on the horizon, which at least has this problem in mind, because they obviously identified with Webflow an opportunity to make sure that requests are controllable. But there are still a lot of attacks that overcome the provided protection. So none of these frameworks has cross-workflow or cross-session protection. So the question is, are we lost already, or is there still hope? We had afterwards a different idea. Maybe it is possible to protect with web application firewalls. Maybe they help and are the silver bullet against all these attacks. Unfortunately, I can tell you they are not. We inspected 28 of these, which we mostly found links to, pointers to on the OWASP website. We found that OWASP top 10 are actually a good selling point, obviously, because every of these 28 mentions this on their website, almost all. I think there were 1 or 2 exceptions. So OWASP top 10 is something that obviously makes web application firewalls being sold. IronB is the only product that seemed to have also, like the frameworks, a good underground to build on such protection, because it is easily extendable. However, we were in this study a little lost, because we were not able to look that much into the products as we were with the frameworks, but we had to more rely on the documentation of the websites, white papers, whatever we found. Whenever we didn't find enough information on the website, we were writing emails and asking for more information or test licenses, but however, unfortunately, we did not get any answer to our email requests. So, this is a list of products that we checked. Again, we cannot say for sure that there is no protection against these. However, as we found that it is obviously not common to have it, it would be a unique selling point. And this is why we assumed that if one of these would be able to protect, they would do marketing with us. And we didn't find any hint of this. Yeah, thank you. And I'm happy to answer your questions.
Bastian, thank you very much for your interesting talk. Any questions? When you have some comments, I will give you them.
I'm not quite sure what your methodology for fact-finding was, because as I develop a lot on Cake PHP, I know that the standard security module basically takes care of all of that. I'm not sure, maybe I'm misunderstanding something there.
You develop a lot on Cake PHP. Yeah, and what was the comment then?
So I'm saying the standard security module of the Cake PHP takes care of all those problems out of the box.
You think it does?
That's what I think, at least. Or maybe I'm totally misunderstanding whether either your presentation or what Cake PHP does.
Okay.
Thank you. Have I still some questions? This might be a solution, of course. Sorry.
So the question is if there would be not only be a workflow ID that is sent to the user and finally sent back to the server, but instead the server would bind all possible parameters and their values to this one workflow ID. Of course, this would be some kind of protection, and this is actually what, as you said correctly, would protect against all these kinds of attacks, even the cross workflow, where the attacker might be able to exchange tokens between two of these workflows. And this is actually the only protection, at least I know, which also helps against this kind of attack. Because the parameters finally define the context of the whole flow, and this needs to be bound together. Yeah.
Actually, I investigated several other frameworks and tried to find the node of this technique, but I failed as well. I didn't find anywhere hints regarding that.
Yeah.
May I can make a little bit sarcastic comment if you on this. We live in modern times, and we have a lot of buzzword-driven architecture, for example, SOA, service-based architecture, and services are stateless. This is why architects and developers love services. And now you come up with the idea of implementing a finite state machine. This is old-fashioned.
Yeah.
Why we need it?
Yeah.
That's the reason.
Yeah,
Okay.
yeah. I think the application principle has moved, and this is why technology has to
Yeah.
move as well.
Okay. A last question, please.
Is there an easy way to audit an application that contains vulnerability of
To what? Sorry.
Audit.
To audit an application. Yeah, this is a good question. So this is a question we were also having in mind to provide more real-world examples. The problem is first that these attacks would be too intrusive for us, but it is definitely not low-hanging fruit. What we found is that checking for injection vulnerabilities was, from our point of view, much easier than checking for these kind of vulnerabilities. What you need to have is a deep knowledge of an understanding of the application to foresee the possible features and how therefore they relate to the requests that belong to this. So you need to understand the patterns that are behind this. With a white box approach, it might be possible. A black box approach, I think, is close to brute force without having deeper knowledge of the application.
Bastian, thank you very much.
Thank you.
And we will see you at 7 p.m. at the Pub San Diego.